Example number 3. A charge of 4 into 10 to the power minus 8 coulomb is distributed uniformly on the surface of a sphere of radius 1 centimeter. It is covered by a concentric hollow conducting sphere of radius 5 centimeter. Find the electric field at 2 centimeter away from the center. A charge of 6 into 10 to the power minus 8 coulomb is placed on hollow sphere. Find the surface charge density on the outer sphere. So here, this is inner sphere, which has charge 4 into 10 to the power minus 8 coulomb. And this is outer hollow sphere, which is given 6 into 10 to the power minus 8 coulomb charge. Now, this is the point P where we have to find out electric field. This distance is 2 centimeter. So we can calculate the electric field by formula E equal to Q upon 4 pi epsilon naught R square. We put the values. So charge is 4 into 10 to the power minus 8 into 9 into 10 to the power 9 divided by R square. So distance is 2 centimeters. So it will be 4 into 10 to the power minus 4. Now we can simplify. So this will come out to be 9 into 10 to the power 5 Newton per coulomb. Now, here total charge will be charge on this sphere, and charge given to this sphere means total charge will be, this is 6, this is 4. So that will be 10 into 10 power minus 8 coulomb. So we have to find out surface charge density. Suppose this is sigma. So this will be Q total divided by area of sphere, outer sphere, whose surface charge density is to be found. So Q total is 10 into 10 to the power minus 8 divided by 4 into pi is 3.14 into radius square. So radius of outer conducting sphere is 5. So it will be 5 into 10 to the power minus 2 square. So we can simplify it. So we will get 3.2 into 10 to the power minus 6 coulomb meter per meter square. So this is answer. Now let's go to next question. We are given here. Let's read the question. Figure shows 3 concentric spherical cells A, B, C of radii small a, small b, and small c respectively. The cells A and C are given charges Q and minus Q respectively, and the shell B is earthed. So here this is cell A, whose radius is A. This is cell B, whose radius is small b, and it is earthed. It means it is connected to ground. And this is cell C, whose radius is small c. Now, find the charge appearing on the surface of B and C. Situation is given. Here charge is Q. This is earth. Here charge is minus Q. Now, let's distribute the charges. So, keeping this earthed. Now, charge is small q here. So, due to induction, there will be charge minus q on the inner surface of B, and let here charge appears as Q1. So negative charge Q1 will appear on the surface of this, and on the outer surface, it must be minus Q, means total charge must be minus Q. So for that purpose, we have to write minus Q, and charge on the inner surface is minus Q1. So this will become plus Q1, because if we find the sum, minus Q plus Q1 minus Q1, that will give net charge minus Q, which was the earlier charge of sphere C. Now, let's find out the potential on shell B due to these all charges. So, charge on A is Q. So, potential on B due to this charge will be equal to, so let's write it as VB, although sphere B is earth. So that will be 0. So let's write VB equal to 0, which is equal to. So due to this inner charge Q, the charge on A, so Q upon 4 pi epsilon naught, and we take, since inside, suppose we are given a sphere and we have to find out potential at this point. So our charge is here. So potential at this point will be due to charge inside, but radius of the sphere will be considered. So here, since we have to find out the potential on this sphere, so we have to consider the radius of this one. So this will be B. So B, and then here charge, induced charge is minus Q on the inner surface of B. So it will be minus Q upon 4 pi epsilon naught B. Then on its outer surface, charge is Q1. So plus Q1 divided by 4 pi epsilon dot B. Then inner surface of sphere C contains charge Q1 with negative sign. So minus Q1 divided by its radius is C. So 4 pi epsilon naught C, and the outer surface of the sphere C contains charge minus Q plus Q1. So potential due to this will be minus Q plus Q1 divided by 4 pi epsilon naught, and its radius is C. So these two terms will cancel out. And from here, since it is 0, so we can rewrite it Q1 upon 4 pi epsilon naught B minus Q1 upon 4 pi epsilon naught C plus Q1 minus Q divided by 4 pi epsilon naught C equal to 0. Or we get, if we simplify, so it will become 0 equal to Q1 divided by 4 pi epsilon naught B minus Q upon, because one term Q1 upon 4 pi epsilon naught C will cancel out. So Q divided by 4 pi epsilon naught C will be left. So this will give Q1 equal to B upon C times Q. So we have got the value of Q1. So the surface of sphere A contains charge Q. So it will remain Q here. And inner surface charge, inner surface of second sphere, which is Earth, contains charge minus Q. So it will remain minus Q. And its outer surface contains charge Q1, and Q1 is B upon C times Q. So here it will be B upon C times Q, and the inner surface of outer sphere contains charge minus Q1. It means here charge will be minus B upon C times Q, and outermost surface of third sphere contains charge minus Q plus Q1, which is equal to minus Q plus Q1 is this much B upon C times Q. So we can take out Q. Then we will be left with 1. So here it will be, we are taking, this will be minus 1 plus B upon C, or minus Q, then it will be 1 minus B upon C, which is our answer. Thank you for watching.